Hi, good afternoon. My name is Elvia Renova. I'm gonna talk about Simeon Dennis Poisson. I'm gonna talk about his biography, his contributions to science, and how his contributions are related to my research. And at the end, I'm gonna give some references. Poisson was born on 1793. He was a French mathematician, engineer, astronomer, and physicist. He was a TA for mathematics with Lagrange and Laplace as advisors. His contributions are very broad. He contributed with some integrals, the Poisson's distributions, the Poisson's ratio, the Poisson's potential, and what is called the Poisson's spot. And he is also well known for his contributions to mathematics, and he used to say life is good for only two things: to do mathematics and to teach it. On the integrals, he has several integral equations. He has like the formula or equation for a cycle, and also an equation for a half plane. He also created the Poisson's distribution, uh, which is useful to model events such as, let's say, like the meteorites greater than 1 meter diameter that strike Earth in a year, the number of patients arriving in an emergency room between 10 and 11 p.m., or let's say the number of photons hitting a detector in a particular time interval. He also contributed to engineering by this Poisson's ratio that is encountered when dealing with the mechanics of materials, where we know that the radial expansion or contraction is related to the axial loading of, let's say, a road element. And the Poisson ratio is a constant, which is the negative of the longitudinal strain over the lateral strain. Then we have the Poisson's potential. Um, Here is the equation that can be found at the Advanced Engineering Mathematics by Barrett and Wiley. And at the end, I also want to mention that he was one of the scientists who thought that the light was, besides being a particle, it was a wave. So this figure shows the Poisson spot experiment, as a light point source illuminates a circular object, casting a shadow onto a screen. At the center of the shadow, a bright spot can be observed. This is the Poisson spot. Well, and how is this Poisson's contributions related to my research, I usually find the what is called the Gaussian integral or the Euler-Poisson integral on quantum mechanics problems. I also realized that in quantum mechanics, the wave nature of light is often encountered, but mostly I find the Poisson's ratio in my mechanics of materials classes and homeworks and research. For example, every time I create an isotropic material for my final element models, the software asks me for the Poisson ratio besides the modulus of elasticity. At the end, I'm gonna give you my references. I have a couple of references from um, the web. Some others are books on advanced mechanics of materials, probability statistics, and a journal of physics. Thank you very much. This is the Department of Mechanical Engineering at the University of Texas at El Paso. No se grabó nada.